In this lesson, I will give you an overview of the overall architecture of Apache Spark clusters. Understanding the components of cluster architecture is essential for scoring well in the architecture part of the exam. Let's dive in. First, let's talk about what clusters are and why they are so relevant for Apache Spark. A cluster is a group of computers. These computers are also called nodes. In a cluster, computers communicate with each other. This is what Apache Spark takes advantage of. Apache Spark is much faster than your laptop or desktop computer. Its power comes from splitting workloads between nodes. Imagine that instead of processing 1 GB of data sequentially, you can just split the data into two 500 MB parts and process each part on a separate computer. This distributed computing ability makes Spark so powerful. What do you think are the advantages and disadvantages of dealing with data in such a distributed way? Obviously, you can get way more done in a shorter time than if you would just be using a single machine. But unfortunately, distributing workloads over a cluster also means higher complexity. First of all, there are many different ways to distribute a workload. Finding the best way is what Spark is really good at. We will learn more about this later in the course. For us as developers, there's another downside. The high complexity of distributed computing means that debugging is not so easy. In a system with so many potential points of failure, it is hard to find the root cause. Lucky for us, Apache Spark also offers some helpful tools here. We will get to know the ones that are relevant for the Databricks certification later. For now, let us explore the different components which Spark uses to make distributed computing in clusters work. A central component of the Spark cluster is the Spark driver. As a user of Spark, this is the component you probably interact with most. When you write code that should be executed via Apache Spark, this code is submitted to the driver. The driver drives the needs of a Spark cluster. Through your code, the driver defines what needs to get done on the cluster. The driver also defines how things should get done. A Spark cluster also has executors. These components are the workhorses of Apache Spark. Executors are just what the name says. They execute workloads after the driver has defined what the workload is and how it should get done. The more executors you have, the more work you can perform in parallel. Remember the gigabyte of data that we talked about earlier? Here with this cluster that has 3 executors, you could split it into 3 parts and give a part to each executor, which would then work on them in parallel. Finally, there's the cluster manager. The name kind of gives it away, but the cluster manager indeed is responsible for managing the cluster. But what does managing the cluster actually mean? The cluster manager is the missing bridge between Spark driver and executors. When the Spark driver has decided what needs to get done and how it should get done, it asks the cluster manager for resources. The cluster manager then books executors on the cluster for the workload to get done. The Spark session is initiated from the Spark driver. It is the entry point for running any Spark workload. In PySpark, the Spark session is a Python object you can interact with. It is the interface to the Spark cluster. Imagine you're on a spaceship. The command bridge of that ship is the driver. The steering wheel or joystick, whatever you use on the command bridge to steer the ship, this is your Spark session. I know I talked a lot about the components in isolation. Let's now trace how information and which information flows between the different Spark cluster components. The Spark session and the executors exchange data. For example, when you want to calculate the average value of a column in a table, the Spark session will help to send that table from the driver to one or more executors. The executors will then do the work, calculate the average value of the column. Not to complicate things too much here, but you should also know that executors can communicate with each other. This helps them exchange data without a single component or node being the bottleneck to expensive data operations. When you focus back on the communication between the driver and the executors, you see that information flows in both directions here. This is because once the executors are done with the calculation, they will send the result back to the driver. To receive the result, you look nowhere else than in the driver. The driver is the place for you as a user and developer of Apache Spark to start workloads and receive their results. Let's talk a little bit more about the role of the cluster manager. What happens right before the driver submits the workload to the executors is actually the following. The driver will reach out to the cluster manager and ask for resources to execute the workload. The cluster manager will then allocate such resources on the nodes of the executors and inform the driver. Then the driver will distribute the workload following guidance from the cluster manager. Although not terribly important for the Databricks exam since it is a little too complex, the cluster manager can also manage the case when the cluster should be used for running different workloads in parallel. For example, you and your colleague could both be using Apache Spark on the cluster for different purposes at the same time. The cluster manager helps make this go smoothly by distributing resources in accordance with your demands and the cluster's computing availability. When I practiced for the certification, it took me a while to figure out this. The Spark components that we see here are only loosely depending on the actual physical computing infrastructure. Generally, not in all cases, but generally, we can expect that there is a separate physical node, a physical computer on which the driver runs. This, for example, can be your laptop. Again, generally there's one node, a physical computing unit or processor per executor. But this node could also be shared between different executors. I've shown this here with the second executor. What is important for the Spark exam is the terminology around these situations. The node on which the driver sits is called the driver node. The node on which an executor sits is the worker node. Where things are physically located on the cluster, which components share which nodes, etc., is something we will talk about later in the course. For now, you only need to know that the Spark components do not need to match the physical infrastructure. We will dive deeper into this topic when we talk about execution modes. I personally find this overview here pretty helpful, which is why I have prepared a mastery map for you. You can find it in the course files. When you have any doubts about the different components of Spark as the course goes on, you can refer to this mastery map. So, let's summarize. We learned that the Spark cluster has three main components. The driver node takes your instructions as code, sends it off to the cluster, and receives the results. The executors are the workhorses. They process the Spark workloads in a distributed fashion. The cluster manager coordinates the resources between the driver and the executors. In the next videos, we will dive a little deeper into the inner workings of driver and executors and learn more about execution modes. See you then.